There we go. Poor little dude.
All right, so look at that very first problem. Try to draw, all right, read through that very first problem. The one about the airplane. There we go. Is there anything in that problem that is unfamiliar to you? There might be one thing, it's okay if you forgot or whatever told us. Is everybody cool with the angle part? Angle of elevation, what does that mean? Since everybody's cool with it.
The one you got like this, the one over here.
That's the angle of depression, but I'm with you. So the angle of elevation, if you look straight out, the angle of elevation would be the angle that you'd have to go through to see something up in the sky. Right? So the angle of elevation is the angle that goes from straight. So if I'm looking up, it's an angle of elevation. Ooh, if I'm in an airplane looking down, it's depression. Right? Not because we're sad, but all right. So the important thing with these problems, the thing that gets people down, well, the first level of thing that gets people down is just writing the appropriate equation in the first place, right? Which is always the biggest problem with word problems. But the second thing that gets people down is they don't even set the situation up correctly. What information should I not bring into play too early in this problem? Say again?
The constants?
Well,
And forgive.
be more specific.
Oh, the elevation?
No. Yes?
Or not?
Time. I don't want to say, because 10 minutes is the snapshot I happen to take. Could somebody else say, no, I want 20 minutes? So I have to set up the situation independent of 10 minutes. All right, so an airplane flies overhead, right? 3 miles up. And then it keeps going, whatever, 300 miles an hour, right? So obviously, the minute it starts going that way, my angle of elevation is changing, yes? Right here, what's my angle of elevation when it's right overhead? 90 degrees, yes? And then it keeps going, so my angle of elevation is now going to become smaller. Okay, like, so can you try to draw the situation at some arbitrary time? I love you guys so much. So here I am, standing here. The plane was overhead, and then I let it fly for a bit, yes?
Yeah.
So put it over there, a plane. You can even just put a dot if you don't want to try to draw a little plane. Everybody should be creating something. Oh, look out, we got protractor in. Yes, raise the stakes. I'm gonna put my plane, which way is that? I can't remember, it doesn't matter. Does it even say it? No, it just keeps going whatever direction. All right, so I can do whatever direction I want. All right, so here's my plane. Weehaw. Somebody cool with what's up?
What would it be the other way? Right on top?
Yeah, so it was right on top of me, and then I let it fly for a while. All right, so it was right here, and then I let it fly for a while. Yeah. I was trying to see if I said east or west. It doesn't really matter, right? Somebody semi-cool with what I've drawn so far. And of course, what shape do we see? That's really good.
Right triangle.
Right triangle, exactly. Not every problem's going to have a right triangle, but you just see if there are right triangles somewhere. They're so kick-ass because then I have trig and I have Pythagorean theorem, I have all this shit, right? Where's the angle of elevation in my picture?
Right next.
Right next to me. I like it. Because here's flat, and then this is how much I have to look up to see the plane.
Yeah.
Let's call that theta. What's this?
That's the height of the other.
Which is 3 miles. And that's a constant. It's always 3 miles. And in case there's any flat earthers, since this is local, I can assume everything's on a flat plane. All right, I'm not proving your theory. Yes.
So you know that like they do this test where like they got a level on a plane and like it stayed level
Yes.
the whole time.
I saw it, which is unbelievably dumb, because levels are based on gravity. So of course, as you go around the Earth, anyway, I'm not going to start debunking flat Earth videos. Just know that they're out there, and it explains a lot. Anyway, all right. Now, what else do I need to identify in here? So my question is, so it passes overhead going 300 miles an hour. What variable is related to that motion? Let's see, how can I say this? So obviously it's the plane was here and then it went there.
dx over dt.
So yeah, it's gonna be this side here, right? So it sounds like you want to call this side x, which I would agree with. Makes complete sense, but you can call it whatever the hell you want to. And so, of course, the 300 mile an hour is going to be what in units then? What's the notation going to be for that? Is what I'm trying to say. Like
T.
miles an hour. Say again?
T.
T?
Or distance.
It's how quickly what is changing. It's how quickly this distance here is changing, yes? So this would be dx dt. All right, let me stop for a minute. Everything I've done is based on what they told me, the problem, right? Everything I've done is something you need to be able to do yourself. So what have I done? I let the plane fly. Okay, great. And then I try to figure out, okay, what do I know? It's 3 miles up, so far over. Here's the straight sight, so I can get my angle in there, and I just naturally made a right triangle. Then they told me 300 mile an hour motion. That's obviously important, because the slower the plane's going, the less quickly this angle is going to change. So that's a huge part of the problem. So I need to have a variable that catches that motion. I really want this to make sense. So one huge part of these problems is, what variables do you need to define given the situation? So yes?
Speed and distance.
Yes, so we got this distance here. It needs a variable because it's changing, right? That number matches with the rate of change of that variable that we just created, right? Do I care about this?
No.
I don't give a shit about that, so let's leave that alone, right? Do you guys see that? There's nothing in the problem that says I need to know this. Okay. But I need theta for sure. And what's the question one in symbols?
How many 10 minutes?
In symbols. In symbols.
Oh, d theta over
Yes,
dt.
d theta dt. So they tell me this. They tell me this. They don't tell me to make the picture. They tell me enough information I can make this picture. And then they ask me this. So I need an equation that relates what I know with what I don't know. So I need an equation that somehow relates theta and x. Because what's important on these problems is the motivation. What is making me, what made me draw the picture like that? What made me pick a variable here? Right? So what equation can we use? What relationship is there that relates what I don't know with what I know?
Tangent.
Yes, tangent. So tangent theta is what?
Y over x, so 3 over x.
3 over x. Why is it okay to put a 3 here? Because it truly is always 3. If I let time go, it's still 3. Right? Yeah, like it. Now, you can do something to make this a little bit simpler. It's up to you. Because what am I gonna wanna do with this equation now?
Take the derivative.
Take the derivative, right? You could take the derivative as it is. Or I could do a little something. It's up to you. What do you guys wanna do? You wanna do the derivative as it is? Can anyone see something we could do? Why is this kind of worse than it should probably be? Because where's my x?
The bottom.
On the bottom.
Multiply by x.
Yeah, but then you'd have like a product rule over here.
That's true.
Can't you just make this cotangent? What's cotangent mean?
X over 3.
X over 3. Now, do you have to do what I just did? No. It just makes the next step easier. Yes? Okay, let me stop for a minute. A lot just happened, right? So there's the visual modeling, which is the first step, because that's where you identify several things. You identify where things fall, you identify what you need to know, and then you even identify, is there anything visually that tells me what equation I'm gonna use? Yeah, this big ass right triangle. Sweet. Right? And anytime you have angles in right triangle, you know it's gonna be some kind of trig relationship. It's not gonna be Pythagorean theorem, because again, I don't care about this. Take that guy's derivative.
Negative cosecant squared.
Negative who to what?
Oh, never mind. That was a rhetorical question.
That's a rhetorical answer. I like. You capturing everything? Yes. Alright, so what's the derivative of cotangent? Let's see if you guys remember what's happening. What are we taking the derivative with respect to?
Theta.
No.
Right.
Time. Right? I'm letting time pass. So what is that? Is there any time variable in here? No. Well, what's happening to theta over time?
Change.
It's changing. What's happening to x over time? Changing. So they are both functions of time. So this is the big thing with related rates. It's like implicit differentiation, but very often with respect to time. So what does that mean is going to happen? Derivative cotangent is?
Negative cosecant squared.
The derivative.
Derivative of theta with respect to? Time. Which is good, because that's what they freaking asked me for, right? So another good thing is once you start doing derivatives, you've written for yourself, because you're smart, and you're going to do my suggestions, what they tell you in symbols and what they ask you in symbols. Because if you don't see this, you're screwed, because how can you solve for it? So you did something wrong. Does that make sense? You want internal checks and balances to make sure you're on the right track. Equals, everybody cool, this is 1/3 x. So what's the derivative of 1/3 x?
It's 1/3.
1/3?
Oh, d theta dt.
No,
I mean,
Dx over
dx dt. Which also makes sense because we know what dx dt is. Yeah. Now there's one little evil thing here. Do I have everything I need? Do I have dx dt? Yes. I don't need d theta dt because I need to solve for it, yes? What other value do I need and do I have it?
Theta.
Theta. Do we know what theta is? No. And when do I need to know what theta is? Because isn't theta always changing? What have I not used yet? So I need to know what the angle is at the snapshot. So at 10 minutes, how the shit are we going to figure out what theta is after 10 minutes?
Pythagorean theorem.
Does the Pythagorean theorem say anything about angles? Just the fact that you need a right triangle?
Yeah, okay. Oh, ooh.
No. Yes.
You can put, depending on how fast the plane is going,
We know how fast the plane's going.
so then you multiply that by 10.
Not 10.
Or well, you gotta change the
If it was 10 hours.
Yeah, since it's going to miles per hour, you gotta change it to like,
I love it.
divide like whatever the 10 minutes is.
Yes, so
by miles
if
per hour.
so snapshot. So at the snapshot, what is X gonna be? Let this sucker go for 10 minutes, which is what fractional part of an hour? 1/6. So if I let this thing go for 1/6 of an hour, 300 times 1/6 is 50. Do you see how I brought the snapshot information at the end? And why did we do it? What was the motivation? Because I need to know what the freak theta is. Okay. So at the snapshot, X is 50. Do I have a nice right triangle into? Can we figure out the angle is? Yeah. In fact, we could be even better than that. I don't need to know what the angle is. I need to know what cosecant of the angle is, don't I? I really want you guys to understand. Never, do I really care what theta is? No. I just need to know what cosecant theta is. And why is that better? Because the angle is going to be some inverse tangent bullshit. You guys see that? Anybody see that? Who gives a shit? Because I just need to know what cosecant is. If I knew what cosecant was, I could square it, put it right there. So what do I need to know? So now I know this is 50 at the snapshot. That's 3. What's cosecant in general?
Adjacent over opposite.
All right, be more fundamental than that. What sides of the triangle is cosecant all about?
Adjacent over opposite.
No, that's cotangent. I think it's tangent. I don't know.
Hypotenuse over opposite.
Socotoa, yeah.
Hypotenuse over the opposite side.
Yeah, so it's the hypotenuse over what? Cosecant is like sine likes y. Sine is y over h. Cosecant must be h over 1. Do we know what this is? No. So now I need to know what this is because I need to know what the angle is. I need to know what cosecant is, right? So what's this then? Given that this is 3, this is 50.
So, squared plus.
Square root of
25
25 over 9. Yes? So what is the cosecant then? Of the angle. What did we just say? What's the cosecant in it? So it'd be square root of 25 over 9 over 3. And what's the cosecant squared?
2509 over 9.
I really desperately hope you guys see what just happened, right? I need cosecant squared. All right, well, let me set up the triangle, get what cosecant is, square it. Yes?
I'm sorry, where did you put 2509 from? I lost it.
Oh, okay, okay. I know 3, I know 50. How do I get the hypotenuse? Good old Greek dude, right? Don't I do 50 squared plus 3 squared equals this?
Oh,
Yeah, okay. So 50 squared, 2500 plus 9. I like it. Good old Greek dude. Stole all his followers' work and said it was his. Oh well. That's history is really. And I just really okay. So I set up a picture that represented any time for the plane. I caught a relationship that related stuff I knew stuff about and stuff I needed to know stuff about. Took its derivative, and then I stepped back and I said, oh shit, I don't know theta. Okay, let me go figure out what that is at 10 minutes because I need to know what that is. And then we realized, well, it's better to know cosecant theta. So let's see, what does this look like now? It looks like negative cosecant squared times d theta over dt equals 1/3 dx dt. So 1/3 of 300 is 100. So d theta dt equals 900 over 2509 negative that. It's like we'll just multiply by the, yes, just algebra after that. Why does it make sense that it's negative? Because as the plane's flying away, what's happening to the angle that it takes to look up at it? It's getting smaller, yes? So that's why it's negative. It makes sense. It's negative because it's getting smaller. What are the units?
Miles per minute.
No, come on, what's this?
Theta.
What units? What units are the angles in?
Theta.
Thetas, I love it.
Radian.
Radians!
Yes.
And what units are time in this problem?
Miles per hour.
Miles per hour, so time is hours. Radians per hour.
Okay.
Good. Okay. Dream about capital. Yes.
Why did you put the square root of 2509? Like, why is there a square root there? Is that like in the function or?
Nope. So you know a squared plus b squared equals c squared. So 50 squared plus 3 squared equals c squared. You're gonna have to take a square root to get c. There.
Oh.
Yeah. Okay. All right. So that's the kind of problem we're dealing with. The thing is, again, people seem to think that they're supposed to know ahead of time what they have to be worried about. When did I ever go back and start doing shit with the 10 minutes when I realized, oh shit, I gotta know that value? Then I went, right? So, all right. Well, okay. This is too bad. I don't have another problem on there with like creating your equation. Maybe I'll steal one out of the book because I want us to do that right now. The next problem is sort of like I gave you the equation already, which is no good. So let's do one out of the book. Let's see. No, that's the same thing. Okay. Oh, that's crazy. Let's not do that. Yeah, okay, this one, we already did one like that. All right, here we go. Let's try this. This looks freaky. So let's see. So everybody got what they wanted from this, probably more than you ever wanted. Yes? So that's the same problems. All right. Here we go. So let's say we have a ladder up against the building. They love these ladders. All right. Oh, I'm drawing a picture for you. I'm supposed to. So we have a ladder against the building, and it's sliding. Sliding at a rate of 0.15 meters per second. That doesn't sound like it's a good thing. At the moment when the bottom of the ladder is 3 meters from the wall, it slides away from the wall at a rate of 0.2 meters per second. How long is the ladder? Ooh, I like it. All right, black your bit here. So the ladder is leaning against the building. It's sliding down at a rate of 0.15 meters per second. Correct. At the moment when the bottom is 3 meters away from the wall, it's sliding away from the wall at a rate of 0.2 meters per second. Yes?
Is it talking about the top is sliding down or the bottom is sliding?
Right here, this is the top is sliding down, correct? Yes? Sliding down the wall. This one is sliding from the wall, right? So can you, first off, draw the picture. All I did was draw a big box for a building. I didn't really give anything away. Okay. And everybody just, I'm gonna do my ladder like that. Why not? So I'm trying to go save somebody and put the ladder up there, and I turn around and the ladder starts, and she's going, how long have you been doing this job? What do you need to give a variable to?
Building height, ladder, alright.
Oh, okay, so not the building height, I don't give a shit how tall the building is, but
Like the.
this location, yes?
Yeah, exactly.
This distance here. So what do you wanna call this?
Why?
Is it one in it? Okay, here, one. It's a bench, okay. And of course, why is it, I mean, physically it just makes sense. You wanna know where that thing is, and again, from the problem, I know how much that distance is changing, so I need a variable for the damn thing. What else do I need a variable for?
Bottom.
The bottom, I love it, because again, it tells me how that's moving, and it kind of makes sense that I'm going to want to know this. So what do you want to call that?
X.
Holy shit, all right. Do I need to call this theta? No, I don't, right? There's nothing about the angle up here.
I thought that we know the distance from the bottom at one point in time is 3 meters.
At the snapshot,
Oh,
if this ladder is sliding at this rate, isn't that constantly changing?
yeah.
But then they take a snapshot and say, right then, what's happening? That, I want to bring that in later. So I love it. You start to really see what part of this problem is the snapshot, the part that I don't want to bring in too early. Because otherwise you'll think that's a constant, set up an equation, it's derivative is 0, and the whole thing goes to shit. Because you've lost everything. What can we identify now? What is this in symbols?
Derivative of y.
With respect to?
Fine.
Time, I love it, right? Now that we've given that a variable, I can identify what they told me. What's this? The x dt. Now here's the last thing. What are they actually asking me for? How long's the ladder? Have we put that up there yet? What do you want to call it?
H.
Or you can just call it
L.
X
There it
squared.
is. L for ladder and length and doesn't matter though. You can call it H if you wanted to, for whatever reason, right? Your favorite ladder company is the ratio of ladder companies, so we call it H. I don't know. You have a, does everybody have a favorite ladder company? You really should. Does everyone understand that this problem does not require me to bring the angles in? Nothing in this problem that says anything about the angles. But what's important about that triangle, it is definitely a right triangle. And now that we got all the parts identified in my picture, what equation can we set up? Of course. That relates everything that I want to know with what I know.
Pythagorean theorem?
Now you're in there. It's crazy.
X squared. Y squared. Equals L squared.
Now you gotta remind yourself, is L a variable? Does it change over time? No. got. They could have said it's an extendable ladder. No. It's a set length ladder thing. They got. But what's most important up here is not this specific problem. It's, do you understand what pushed me to do everything I did? Capture the picture. Think about what they tell me. Think about what that relates to. What do I need to give variables to? Oh, go back and give them names so that when I start doing calculus, I can make sure they show up. So here they're asking me for L. L is what I need to figure out. Okay, what do you do now? All right.
2x minus the x of 15. dy. X dy of 15. L squared. Wait.
Is the ladder's length changing over time?
No.
So when I take it through, do I get zero? I really want you to understand. You can either be right now sitting there going, well, what the shit do I have to worry about stupid letters, putting DT shit, and he's not even doing it there, and he did before, what the shit? Or you can realize, L's freaking constant, of course its derivative is zero. Yes?
Yes.
All right, now you step back. Now, of course, you could kill the twos and stuff. Everybody cool with that? Right? Kill the twos. Let's just do that. And now you step back and you say, okay, what do I... not know? Now here's what's... Is everybody... All right. I don't know if you guys... All right. What are we trying to solve for? L. Is it show up in there?
No.
All right, don't worry. Because what do I... Don't worry. Do we know dx dt?
Yeah.
Yes. Do we know dy dt?
Yeah.
Yes. Do we know x?
Yeah.
Ah,
It's a snapshot.
snapshot. So at the snapshot, that's when you bring in, because now that you've taken the derivative, you know how the rates are related forever. Now you can bring in your snapshot. At the snapshot time, what is x? They tell me it is 3 meters, right? So at the snapshot, x is 3. All right, green, you're not so good. So dx dt is 0.2 plus, do we know what y is at the snapshot? And then here's where things get interesting. Yes?
We would if we know what the x is, right? Because
Well, we know what the x is. It's 3 at the snapshot, right? Don't overthink it. How do I get y? Do I know this side? Yes. Do I know this side? Yes. It's L, right? Do you guys understand? Isn't L a constant? How long is the ladder? L. So what's y then? Would it be x squared plus y squared equals L squared? Exactly what we have here. So if I have x squared plus y squared equals L squared, what's x at the snapshot? 3. I don't know what y is. So now I can figure out, is that cool? Subtract 9. And then to get y, I just square root it. And normally I'd have to do plus or minus. Why do I not have to do plus or minus?
Can't have negative.
You'd have a negative, exactly. That would be freaky as shit. Fire department fell into a weird dimensional rift. Negative distance. I love you guys. This is such a beautiful problem. And that's not, the weird part about this problem is, I don't know this is a number, but I know it is a number. I don't know what the number is, but I know it's a number. So it just acts like it's a number, it just goes through. So now what do I put in place of y? That. And what's dy dt? 0.15. And I know that looks gross, but who gives a shit? Multiply, subtract, divide by 0.15, square both sides. Can't you just attack that with a bunch of algebra? Yes? This is where it gets a little boring, but oh well. How you doing over there? Here, some of you guys are like, it's always boring. So this would be 0.6, subtract that. So it'd be square root of L squared minus 9 equals negative 0.6 over 0.15. And I think I gotta be more careful. Dy dt, is that increasing or decreasing? Decreasing, so this should really be negative. Bam, there. This is, as you let time go by, that height on the building is getting smaller and smaller, correct? So the derivative should be negative. 0.6 over 15 is 4, is that right? Yeah. So you get L squared minus 9 equals 16, L equals 5. Crazy, 5 foot ladder. No, you guys agree?
I have a question.
Yes.
So I thought, since it's just the rate at which it's sliding, it doesn't necessarily have to be negative. It's like, I thought,
If-
yeah, the distance is coming down, but the rate doesn't necessarily mean like it's coming down slowly.
If the rate of change of height on the building is positive, that means over time it's getting bigger. That's what that means.
Oh, okay.
So it
that's
must be
why.
negative to match with what we know.
Okay.
And I should have been more careful here. What told me that I had made a mistake over here was I had a square root equals a negative number. So I'm like, okay, I must have been a little loose with something.
Wait, wouldn't L equal root 5 because L squared minus 9 equals 16, so
L squared equals,
L squared equals 5.
no, come on.
Wait,
Okay,
I see what happened
no worries. I make mistakes, I totally do.
Everything's up there.
Alright. This is different, right? You have different things to have to worry about. So let me let you do this. On number 2, 2 is more of just a straight up, can you just work with an equation that's already given to you? So can you do 2a? Like, they've already got the equation there, right? And that's normally the hardest part. That's what took us the longest up here, is to get the freaking equation put together. They've given it to you. So try to do 2a on that worksheet. Yeah. Or did you not give it? While you're doing that, I'm going to give you guys the practice test. You can just put this away for now. One over there. So just put that practice test away for now. Don't freak yourself out. what is this in symbols that they tell us? No, in symbols.
dx over dt.
No, no.
dv over dt.
dV over dt. I don't know that because it's volume per time, right? Cubic second. So it's the change in volume over time. What's the symbols for what they're asking me?
dr over dt.
And people that skip that step are going to make really simple mistakes. It's a great step. You just summarize for yourself and you give symbols to things that they tell you, right? Go on. What do you guys get when you this derivative?
dv over dt equals.
4 pi r squared.
Good. The 3 comes down. Cancels that 3, so 4 pi r squared
Times dr over
times dr dt. So now you can kind of step back and see, all right, do I know dr dt? That's what they want me to figure out. Okay, do I know dv dt? Yes. Do I know r at the snapshot time? Yeah, I do. That's nice. So I want you to realize, so I got this big ass balloon, right? And there's, it's leaking out at a certain rate. Over time, the radius is not changing at the same rate. It depends on, how freaking big this thing is. So that's why I have to tell you, at a time when the radius is 24 centimeters, how quickly is the radius shrinking? Because then I wait a little bit and it's not going to be shrinking the same. So this R, the snapshot time could be any time, 24 centimeters, then I wait a little while. What if I wanted the snapshot to be 12 centimeters? Well, I can plug a 12 in here. But this equation tells me how these rates are related at any time. That's why you don't want to bring the snapshot in too early. So now, what do I put here? 4.
4 centimeters.
And then in case of R, 4. And then DRDT, that's what I'm trying to figure out. It's going to be something silly small, right? Because the 4s cancel. You divide by 24 squared pi. What's 24 squared? 576. Sorry, that took me a while. And then whatever the hell that is. Right? What would the units be on this? Don't overthink it. Look at this. What's that mean? Radius. What's that in? Centimeters. Per. Yeah, minute. That's the beautiful thing about this d by d thing, that notation. Did you just see what the top is and put the units for that? See what the bottom, put the units for that. There's your units. And then, is everybody do this? What is this? If you divide this. This is true.
Like 0.005.
0.005?
It goes on.
Blah, 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 blah?
Yeah.
So that's what you call a slow loop. Yeah. Okay. That should be enough to get you started in 3.9. So what I think I'll do the same thing I did last year, last semester, sorry, which is I'm gonna have at least one relatively straightforward related to each problem on the test. But I'm not gonna make 3-9 homework due on the day of the test. Does that make sense? So do you still wanna do some of the early part of 3-9? Yes, you do. But you don't have to finish all of it. Hopefully that makes sense, yes.
Wait, what section did you say was extra credit?
3-8, is that right? Yeah, 3-8, extra credit. All right. Cool. That's enough for today. So everybody's got a practice test. I'll have the answer key Monday, and our test is on Wednesday. Well, the one we had today. Yeah, we just had a quiz today.
Can I take it on Monday?
No. What I'll do, so if you miss a quiz, then grade on your next test takes the place of the missing quiz grade. So you can have a copy of it, see what it looks like. What's your name again? Okay, Isaac, okay. Because I don't have any for you, okay. And yeah, you got a practice test. Yeah, so does that make sense? So it's not gonna be a 0. Whatever you make on your test, I'm gonna put that same grade in the quiz spot. So your test just counts a little more.
Oh, okay, I see.
Yeah.
Okay, cool.
So you won't have a 0 in that quiz.
Okay.
Yeah.
Cool, thank you.
Bye, Professor Waller.
See you, Carmen.
Great weekend.
I'll try. You too. See you.
See you Monday, Waller.
Take care.